Welcome back. I have one last piece of information that's going to blow your mind. And after this, you can relax saying that, all right, no more surprises. The hardest part is over. It's going to become easier and easier as we learn how to use prototypal inheritance. Now, this statement is true. Only functions have the prototype property. What does that mean? Remember this? How proto points to the prototype object? Well, the thing that contains this prototype object is always a function. If we go back to our multiply by 5 example, we ask ourselves, is multiply by 5 a function? Well, yes, it is. Then it's a special type of object. It has an invocable piece of code. It has an optional name property. It can have its own properties. And we can use proto to link up to the prototype. But multiply by 5 itself, because I just said it in that statement, every function has a prototype property. It has prototype. Let's have a look. If I clear this and do multiply, let's run that function again. Function multiply by 5. And I'll do multiply by 5 dot prototype. And look at that. I have a prototype. Now, this prototype itself is pretty empty. When we create a function like this prototype we don't really use. It just gets created, but we never really make use of it. Because prototypes, although they are a property on all functions, the only time we really use prototypes is using what we call constructor functions. Constructor functions, they usually start with a capital letter, and they contain the actual blueprint or prototype that we use. So for example, if I do multiply by 5 dot underscore underscore proto, which links to that prototype, we already know that function dot prototype is going to equal exactly that. If I do multiply by 5 dot proto and then up the chain again, which will be the object constructor, well, if I do object dot prototype, I get the same thing. But now you're asking yourself, whoa. You just told me that prototype properties only exist on functions. And this is where it gets a little bit tricky. Because this object is something we've talked about before. It's the base object. Because if I do multiply by 5, prototype, and then one more time, proto, we'll get null because we're past this base object. But if I do type of object here, I get function. What? I know, super confusing. Type of object is a function because, well, it has the prototype property. Remember when I talked about standard built-in objects in JavaScript? And we have all these things like fundamental objects like object, function, boolean. We have number and dates like number, math, date, string, all with capital letters. Well, if I click on object here, we see that this object is the object constructor that creates the object wrapper. Remember, in order for us to perform an action in a program, we have to have a function, right? That's what a program does. It stores data, and we use functions to manipulate that data. So when we do something like const object equals object, underneath the hood, JavaScript has to create that object. And in order to create that object, well, it uses this object constructor. Just to prove to you that that's the case, if I do type of an empty object now, look at that. I get object. because this is now an actual object that we've created from the object constructor. Now, I am going to warn you, and I know I've been bugging you about this. This can get pretty hairy and complicated, and it's hard to map your head around. But if there's one thing that you take away from this video, is that every function has a prototype property, and it references to an object used to attach properties that will be inherited by objects further down the prototype chain. The last object in the chain is this built-in object.prototype. Remember that difference. Object is a function because it has the prototype. Now, the object.prototype is what we call the base object. That's the very last piece or the very last object that we can look for properties on before we point to null. I told you that your brain was going to hurt after this one. Oh, and one last thing. If I created, let's say, an object equals to an empty object, will I be able to access object.prototype? Nope, it's undefined. It's not a function, right? If I do, let's say, an array, so const array. If I do array.prototype, is that available? Nope, it's not a function. What if I do a string.prototype? Is that available? Nope. We don't have prototype. Because, well, that's just a primary type. Functions have a prototype. And you may notice here that we do have booleans, functions, we have numbers, we have strings. So if I do something like string.prototype, well, yep, we have that. And strings have all these methods from the string constructor that they can inherit from. Even though I did string.prototype here, underneath the hood, when I try and access a method on this string, JavaScript is going to convert it into a string object and look up the prototype chain for these methods. That way, we can perform all these actions on the string type. To review, everything in JavaScript is an object, and arrays and functions in JavaScript are objects. They inherit through the prototype chain from the base object. You can go up the prototype chain looking for properties on this prototype property. This prototype property also has the proto property inside of it that links higher up to the next prototype chain. Proto always points to prototype, and we also remembered that only functions have the prototype property. And at the end of the day, this was useful for us because using prototypes, we avoid repeating ourselves. We avoid adding the same code over and over and over and being inefficient with our memory. But we can also start creating some interesting programming paradigms now and practices using what we learned, both prototypes and closures, to write some really powerful programs. We're almost ready to get into the next section. I'll see you in the next video.